teamwork. This is Physicalculus. Our team is divided by
Krista
and Marco. Our teachers are Hugo Choa and Ignacio. Group number 6. Our problem says a rock is thrown outboard and its position function at any time is given by Este equals minus 16t squared plus 64t plus 96. We have to calculate the derivative of the position using the limit definition, graph it, and then what is the connection between position, velocity, and acceleration, and calculate the time when the velocity is the half of the initial velocity.
We're going to calculate the derivative. Our derivative is minus 16t squared plus 64t plus 96. We're going to use the formula f of x plus h minus f of x over h. Because h tends to 0, we're going to clear having minus 32t minus 16h plus 64. We're going to eliminate h because it's equal to 0, and our derivative is equal to minus 32t plus 64.
Now B, we need to graph the position function showing at least 3 points where the rock is passing through. We can see it in the graph that is over there. And letter C is given the function, the velocity function equals minus 32t plus 64. We need to graph it and use at least 2 points, and we can see it another time. Then letter D, given the acceleration function, acceleration is equal to minus 32. Graph this function using at least 2 points, and we know the acceleration is always be constant. What is the connection between position, velocity, and acceleration?
Well, Marco, the position is the most important factor because it will determine if the acceleration is going to be positive or negative depending on the direction in the Cartesian plane. And at the end, the acceleration will need the direction and the initial and final velocity to be solved.
We need to calculate the time when the velocity is the half of the initial velocity. So we need to remain that our velocity function is vt, that it is equal to our derivative, that is minus 32t plus 64. We need to remain this. And now, using a formula of physics, we can use that our derivative is equal to SO plus the initial velocity minus gravity time squared divided into 2. So we use our derivative, that is 96 plus 64t and minus 16t squared. So we need to remember that this is the initial position. This is our initial velocity. And now this is the height about our derivative. This is our initial velocity. So we need to find the half of the initial velocity. So we divide 64 into 2. That is 64 into 2 is equal to 32. Now we replace the 32 into the t. 32 is equal to our velocity formula. That is minus 32 plus 64. Minus 32t plus 64. So we pass the 64 into the other side, doing a minus. Minus 64 plus 32 equal to minus 32t. Now we have that minus 64 plus 32 is minus 32 equal to minus 32t. Minus 32 divided into minus 32. We have time. Now minus divided by minus is positive. So we have that is plus 1 second. Time is 1 second. It can be concluded that the use of the formula of derivative can be useful to solve physics problems. Also, the parabolas that are occasioned because of gravity, velocity, and acceleration, the direction and the angle from where an object is thrown. And a clear example can be the basketball game when a player throws the ball to make a basket.